So today's lesson is going to continue our study in polynomial equations, but today we're going to investigate solving them. Now, in order for us to do that, we need to recall our factoring skills that we've already learned and build from those skills. So remember that when we're solving polynomial equations, we're looking for where that graph is going to intersect the x-axis. Now we can do it graphically, but we can also do it algebraically by factoring. So this first slide is a review of how we factored quadratics. Now these techniques aren't exclusive to just quadratic functions. We can do these for most even functions as long as they follow simple rules. Like if the first degree is 2, the second degree would have to be half of that, which is 1. So technically this could be a 4, and then this degree a 2, or a 6 and a 3. And then that pattern will work to be factored using those quadratic techniques. Now, you'll recall that when we're factoring these, when our last sign was plus, that means that our two binomials had the same sign, and it was determined by the second sign. If this was a plus, they were both pluses. If it were a minus, they are both minuses. And if the third term, is negative, then we always would just have one of each, regardless of what that middle sign is. So then we go to factor and make sure that it's not prime, because some of these quadratics will be prime and not be able to be factored. So this is what it looks like if we have 3 terms. Now let's go back and look at if we have 2. Now we learned this and talked about this at the end of Algebra 2 and even earlier this year. This is the difference of squares. You'll recall that I would call this a DOS, difference of squares. It factors nicely into an a minus b, which is the square root of these terms, times an a plus b. Now this is the big one I need you to remember. We do have factors for a DOS, a difference of squares, but we don't have factors for a sum of squares. So when you come across this guy, say you would have x squared plus 100. It is not factorable. This is a prime, so you won't find any factors that will work if this is a plus and these two are perfect squares. Now, if they are the difference and sum of cubes, this is new to this lesson. These are 2 factors that we've not talked about yet this year. So the difference of cubes always factors into the cube root of each one of these numbers, a minus b. Once you find the cube root, then it becomes the first number squared, the first number times the last, and the second number squared. Now notice whether it is the difference of cubes or the sum of cubes, your factors are exactly the same. What changes are the signs. So if it's the difference of cubes, it starts minus plus plus. If it's the sum of cubes, it starts with plus minus plus. Notice that this last term is always a plus sign, and what changes are these 2 signs. If it starts with a minus, it starts here in the factors as minus plus plus. If it starts as a sum, our first factor is a plus, and then it goes minus plus. So just remembering the factor placements are the same for each set of factors, but it's the signs that change. Now, again, these are new to us, so you want to make sure you get those in your notebook or you keep this handout handy when we get to the factoring. All right, now, this is something that you learned at the end of Algebra 1, but we're going to build on in Algebra 2. So this is factoring 4 terms. Now, not all 4-term equations are factorable, but this is a technique that we can use and see if it is factorable. So what you can see being done here is they're trying to factor this 4-term polynomial. So what they're doing is they're taking 2 pieces at a time. So you can see x cubed plus 3x squared, they started by finding a GCF, just like we always do. They pulled that GCF of x squared outside, leaving a factor of x plus 3. Then they did the same over here. They pulled the GCF out. They're looking for that GCF. They pulled a 2 out, and they got a factor of x plus 3. Now here's the commonality of these two pieces. They both have an x plus 3 in common. So what they're going to do is they're going to factor again, but they're going to pull the GCF of the whole this time, which is x plus 3 out here, and then they're going to be left with that x squared plus 2. And those are going to be the two binomial factors. Now, oftentimes you'll be able to utilize this technique. If there's 6 terms, you can try 2 at a time or 3 at a time. So this is not exclusive to 4 terms. It could work for a higher number of terms as well. All right, so this sheet that I have on Google Classroom, if you could print that, that would be very helpful for you to have in front of you to have all of the techniques, the 2 terms, the 3 terms, and the 4 terms, so you can utilize when you're factoring and in the factoring process. All right, so let's just look at some factoring before we start to solve these polynomials. So remember, just as we always have done all year, we're always going to look for that GCF first. So in each one of these terms, I can see that they all have a 5. So my GCF is definitely going to have a 5. I have an a cubed, an a squared, and an a, so I know that an a will divide into each one of those. I have a b squared, a b, and a b cubed. So it looks like my GCF is going to be 5ab. So what I'm going to do is I'm going to take each term and divide by 5ab. Now I know that you're pretty good at that at this point. So we'll go through this one rather quickly. So 10 divided by 5 is 2. A cubed divided by a is a squared. B squared divided by b is b. Then I will get a 3a, and the b's are going to cancel out over here, minus the 5's will cancel out, the a's will cancel out, and we'll just be left with a b squared. Now remember, I'm not getting rid of that 5ab, I'm just factoring out to the outside. So I'm going to pull that on the outside as my GCF factor. Now if I look here, looks like I got some quadratic terms, but I don't have enough here because of this b to be able to factor this again. If this b were in the middle, I would possibly be able to factor it, but I've got too many variables in odd places to factor again. So this is going to be my final factoring. All right, let's look at example 2. So in example 2, you can see that I have 4 terms. So because I have 4 terms, I'm going to use my factoring by grouping. Now before I do that, I'm still going to look for a GCF. So I don't see any numbers or variables in common with anything, so I'm going to say that my GCF is 1. All right, now I'm going to utilize my grouping. So I'm going to take x cubed plus 5x squared grouped together, plus I'll take negative 2x minus 10 and group that together. So now I'm going to look for a GCF in the first 2 terms, and it looks like that's going to be x squared. So I'll pull that x squared out, and I'll be left with x plus 5. Then I'm going to come over here to my second set of terms and pull out a GCF again. So it looks like in here, my GCF is going to be negative 2, and that's going to leave me with x plus 5. Now you'll notice that in both my first piece and my second piece, I have an x plus 5. So I'm going to utilize that in both of those pieces as my GCF, and that's going to leave me with x squared minus 2. Now I look at that because I see a difference, but I don't see the difference of squares. So I'm okay to be done here. So my two factors are x plus 5 and x squared minus 2. Now, what's nice about these, if you want to go ahead and FOIL that back out and check it, you should get what you started with, because factoring is division and then FOILing is multiplication, and it will take you right back to our starting point. All right, looking at our third example, I've got 3 terms, so I'm going to look for a GCF first. So my GCF, I have a 12, an 8, and a 20. It looks like I can put a 4 into all of those. And then I'm going to look at my y cubed, y squared, and y. So 4y looks like that's going to be my GCF. So I'm going to divide each piece by 4y. That's going to come to the outside, and that'll leave me with 3y squared. That will leave me with minus 2y, and that's going to leave me with minus 5. Now you can see I have that quadratic model right here. Now with that quadratic model, I'm going to go ahead and factor this again. So I have 4y. And I'm going to factor. I know this is a minus, so my signs have to be one of each. So I'll put those in later. That 3y squared is going to factor into 3y and y. I know there's only one way that 5 factors. It's just about the placement. Now, if you want to use that slip and slide method we learned earlier in the year, you can go ahead and do that now too. But I'm going to go ahead and put, I think that 5 should go here. But I'm going to check. I'm going to check my outers, give me 3y. My inners give me 5y. I need a negative 2, so I'm going to make that placement be a minus here and a plus there. So I think I'm okay and factored. So I look at all of my terms and I see nothing else factors again. So I am factored completely. So you'll notice here, we pulled a GCF out, but it still needs factored again. So some of these problems are going to need factoring more than once. All right, so now let's look at another one of those new concepts that we talked about today. This is a difference, and this is a perfect cube. Is 64 a perfect cube? So if I find the cube root of 64, that gives me 4. So yes, it's a perfect cube. So because it's a perfect cube, that means that these are the difference of perfect cubes. Now I'm going to put that model up here for you. So the model was that a cubed minus b cubed is equal to the cube root of each. And then I take the first number squared plus the first times the last plus the last number squared. So because this is minus, I lead off with minus, plus, and the last term's always plus. So let's fit that in here with x cubed minus 64. So my first grouping will be the cube root of each number, x minus 4. The second grouping is going to be the first squared, the first times the last, which is 4x, and the last number squared, which is 16. So I cube rooted each number. I have the first number squared. Now that would be the first number of the new group. The first times the last, 4x, and the last number squared. I check my sign. Since this is a minus, I lead off with a minus, and the second two will be plus. So these are my factors. While I'm here, I want to just do one more of these. So what if I change this to be y cubed minus 8? Actually, I want to make that a plus 8. So I check. I can see that this is a perfect cube, so I'm going to cube root 8. And the cube root of 8 is 2, so this is the sum of two cubes. So I'm going to use this model. A cubed plus b cubed is equal to the cube root of each times the first number squared minus this time the first times the last plus the second number squared. So if I input here y cubed plus 8, that's going to give me y plus 2 when I cube root each number. Then I'll have y squared. I'll have minus 2y, and I'll have plus 4 because I'll have to square that second number. That will give me 4. All right, so this is utilizing all of our factoring techniques. Tomorrow we're going to look at actually taking these and solving these from here. Today I just want you to practice the factoring that we already know how to do and use those new techniques to factor. I hope you have a great day.